1/3. So deep. That makes sense? So moral of this story is if you don't know how to integrate it, try to use substitution.
Oh, there.
My son came home from daycare last week singing like a Bible school type song, and when he's done, he's got this third verse that I've never heard, and he's like, and the moral of the story is, it's so cute coming out the little thing from his mouth. He doesn't even know what moral is, but okay, it's like the white rock song. A flow field is what we're learning about today. It is a visualization of an infinite number of solutions to a differential equation through slopes. Slope fields can be used to check the solution to a differential equation. Or we'll learn a method in Cal 2, it's called Euler's method, that we use a slope field to help us write an estimation of what the differential equation would be if we couldn't solve it. So slope fields are very useful. So this is a picture of a slope field. So this is the slope field of dy dx equals x plus y, and that's the same slope field except with the particular solution drawn that goes through the point 2, 0. I'm assuming this is the point 2, 0 through a particular solution. So we're going to sketch a slope field for dy dx equals x plus y. These will be your favorite questions on the AP exam.
Yeah, I was going to say something. Well, this is my favorite. Like, oh yeah.
No, really. Because if this is the question, part 1 is the slope field, part 2 is the differential equation. You get 6 points from the differential equation, 3 points from the slope field. It's good deal. Okay, so sketch a slope field. A slope field is literally individual slope drawn lines at each point. Well, this is the derivative, right? Which is the slope. So what's the derivative at 0, 0? What is the slope at the point 0, 0? 1. Does everyone agree? What's the slope line with a slope of 1 look like? One down. Most of the time at AP exam it's somewhere between 6 and 9. I have more on this one because I want you to kind of see me draw one, but in fact, would you agree at any place that x is 0, the slope is 1?
Yeah, sure.
So I'm going to save myself a little time in plugging in individual points. Okay, all of these slopes are 1, right? That makes sense? Which, because this one is just x plus 1, all of the slopes are going to be dependent upon the x value. So that's also why I was able to get away with a few more dots on this one, because it's not going to take me that long. What is the slope going to be when the x value is 1?
Oh, it's going to be 2.
On the AP exam, they will just want your 2 to be steeper than your 1. Like, they're not going to get a compass out, measure your angles, or anything crazy. They just want to know that you know that's the slope of 1, so 2 should be a little steeper. And then at 3, the slope would be?
Steeper.
No, sorry, 2. At 2, the slope would be?
It'd still be steeper.
It would be 3, right? And then at 3, it would be?
Even steeper. Oh my goodness.
And then at -1, what would the slope be?
0.
Generally, on the AP exam, they will give you a point for the 0 slopes. Like, they will specifically look slopes at the horizontal y-axis. At -1, -2, sorry.
It'll be -1, so it's gonna be.
And then at -2.
Steeper.
Steeper but negative, right? So we drew a slope field. Find the particular solution y x to the differential equations with initial condition f of 0 equals 0. So I'm going to find the solution. So that's actually a question from yesterday, right? So how do I find a particular solution? I separate the variables. If you were on an AP exam, would you recommend showing this step? Why? You get a point for that.
Got the first part.
At 0, 0, what would C be at 0, 0?
You're looking at
-1.
0.
0? At 0, 0, it would be 0. 0 for x, 0 for y.
C is just disregard it. It's not. Don't worry about it.
So this is the particular solution. I want to, part C says sketch the particular solution on the graph. I actually would not have had to find it to sketch it. So I'll show you that I'm not necessarily going to, no, I could actually draft it up parabola, find the vertex or whatever you wanted to do there. But I'm going to just sketch it from the slope field. I know it goes to the point 0, 0. So that is this point right here, right? The slope field is kind of like a little map of where I'm going to go. So from 0, 0, would you agree I'm going to go down and have a minimum right here at my 0 slope? So if you didn't know, I would say that the minimum of that is at -1. Do you agree? Because of the 0 slope there. And so I'm just going to follow the slope field around and make a curve. So I'm just following those slopes. It's like I dropped a leaf in a stream. Right? It's going to follow whatever those slopes, wherever those slopes go. Or a weather map, whatever.
They use this.
A lot of things. It's differential equations are used in almost every branch of science.
even steeper.
And so you can kind of see what that slope field looks like. Find a particular solution, but we'll kind of see why the slope field looks like it does. We are also getting some differential equations practice. Be careful on the left here. It's not just 1 over y. So be careful. I'm not saying you have to do a new substitution, but think about it.
Slap an L in on it. Oh, good.
Yeah, don't do that. If you do, you will get away with it on this one because what's the derivative of y minus 1? But think about that. If that derivative is not 1, you probably need to do a little more work.
Y over y minus 1.
Don't hurt my heart. No, you cannot do that. You can't split a fraction with the numbers. Is 1/4 the same as 1/2 times?
1/2 plus 1/2.
Oh, let's do 1 over 3 and 1 over 4. Yes, 1 over 3 and 1 over 3 and 1 over 1 is the same as a 4. 1/3 plus 1. No, that's like pre-algebra JoJo. A long time ago. Context, students y. What is natural log of 1? Do you need to know that?
Yes.
And what is natural log 1?
I think it's.
It is 0. Natural log 1 is 0. It's anything to the 0 power of 1. So 0, 0, right? C is 0. So my equation e to both sides. I have to decide plus or minus since my initial condition was 0, 2. If I plug in 0 and plug in 2, this doesn't need to be a positive to make it work out right. Correct? So we are going to leave it as the positive, so y equals e to the x plus 1. Well, for part B, we're done. Okay, for part C, sketch the graph of the solution f of x on your slope field from part A. If I'm going through the point 0, 2, does that look like an e to the x plus 1 graph? Yes. Follows the slope field, seems reasonable. There is a horizontal asymptote on that, which makes sense. There is no domain issues on an e to the x graph, so this domain is all real numbers. Domain of the solution is all real numbers. Randomly. I cannot solve this differential equation. Why? You can't. Why can I not solve this differential equation? It's addition, so I can't separate the variables. So this is one that you would not be asked to solve in Cal 1, 2, or 3. It would be a differential equations class question. So we are not going to try to find a particular solution, but we are going to sketch it. We answered part C. Why are we not expected to solve this differential equation? Because we can't separate the variables. Okay, so on this one, can I play the little tricks I've been playing on the last two with the y value and the x value thing?
You gotta add them up.
Now I gotta add 0, 0
is 0.
is 0. So right here I have a 0 slope. When else will I have 0 slopes?
When x and y are equal to each other.
Opposite signs, right? So like at x being -1 but y being +1, or at x being +1 and y being -1, x being 2 and y being -2, x being -2, y being +2. So you get kind of a horizontal or a diagonal. Okay, when x is 1 but y is 0, the slope is 1.
And then we can do that all steeper.
Okay, so you could do that kind of 0, 1 is the same, isn't it? And -1, 2 would be the same. So you kind of notice patterns as you're doing these. 2, -1. Now, do you have to notice the patterns to be able to do this?
No, but it
Maybe
makes
just plug them in. I think you got it. I will check it if it is class, just come back. Or just check it on. I'll put it in this afternoon if you got it. Either way.
well, that's supposed to be steeper.
Okay, any questions so far? When x is 2 but y is 0, I get 2. So that one is a little bit steeper, and so would all of these be that same steepness. And then the next one would be
Steeper.
a slope of 3, correct? And then a slope of 4, and then a slope of 5. They just keep getting steeper as they go up that diagonal. What about at -1, 0?
Oh, that's like -3.
So all of these on this diagonal would be -1. Again, if you don't notice that, don't go, I don't understand this. Yes, you do. You just didn't notice that. Just do the derivatives, do the slopes, plug, draw a little line. You'll probably notice the pattern eventually. You might not have noticed it quite as early as I did. What about down here? Steeper negative, right? 2,
Even steeper.
3,
Steeper in this case.
5. Yeah.
It's like a straight up and down line.
So that's my slope field. Right. If the particular solution passes through the point 1, -1, sketch the solution. Well, this looks like a bottoming out point to me, doesn't it to you? Because it's a horizontal tangent, and I know the slope to the right is positive slope, and the slope to the left is negative, so that's actually a minimum value. You see how much I figured out from this slope field? Even though I couldn't find the function, I've been able to figure out a lot about this function from this slope field. So I'm going to follow. Looks like we've got some kind of horizontal asymptote happening here, because I kind of get stuck on that line once I get to it. So when I'm following this slope field. Any questions about this? So I can get a really good picture of the equation, even though I couldn't find a solution by hand. What do we got? Okay, so multiple choice or matching. I would not write these down. I would just get these off, like maybe print this notes page or something. It just would take you too long to draw them all. I'd rather you just think and go print the page off the deadline later if you want the page in your notes. Yes, so here come up. So the slope match each slope field to the function that could represent it. So those are the functions, not the derivatives. They are the functions going to look for a multiple choice. You'll have to go to a different topic. Okay. So, y equals 1. What do you think that one is? What do you think? Y equals 1. Everyone agrees? D, y equals 1, D. Okay, and y equals x. Which one do we think? How are you picking these out? These are just the, right, you kind of see a bunch of the function, right? So vertical shifts, why would they be different vertical shifts? What do you lose in the derivative? What goes away? And when you say the constant goes away, so you lose the vertical shift, so you just don't know where your function started at. X squared would be x squared. Oh, C, yes, definitely. I think so. 4. It's a cubic. It looks like a cubic.
Boom.
1 over x squared. 5t. Okay, so what are we asking ourselves when we're deciding? Well, we know there's a vertical asymptote at 0, right? We know that. So we see vertical asymptotes on A and G at 0, and it seems we've got vertical asymptotes on this. So what I need to know is x approaches 0 from the left and the right. What am I? Is y approaching infinity or is y approaching negative infinity? Is really what I need to know, right? We agree? So what if I plug in negative 0.00001 into x? It becomes a positive, really big number. So I think A. So we're going to agree. Sign. Cosine. Natural log must be G. Does natural log also have a vertical asymptote at 0? Yes. The left-hand side of this slope field is the plus and minus that you would get if you were solving a difference. AP problem. This is a real AP multiple choice problem. Shown above is the slope field for which differential equation? I want to try to look for little hints, and I found some earlier. The first thing I'd say is, what do you know about A? We did it, and wouldn't all on all of the x values, the slopes will be the same? Is that the case for this? No, they're not. So I'm going to say no on that one. And if there are any with only y's in them, I'd say no on the only y's as well. Why would I say no on the only y's? Because they're not the same on a horizontal line either, right? Does that make sense? What I would look for is, do you see all those horizontal lines? Okay, those are when the slope is 0, correct? When does the slope seem to be 0? When x and y are opposite, right? When would that happen? Okay, I'm sorry, this one only had x's to the back. This one, when y is 0, what would you get? Undefined slopes, wouldn't it? Which would actually be represented by a vertical line if you decided to put something there, right? This does not stay vertical the whole time, right? So it's not that. So that's a couple of things you can look at to kind of pick out without having to draw the entire slope. I will tell you, TI-89, draw slope. And do graphs. You really will want one in college algebra. Kind of calculus. negative